carbon dioxide is a natural gas produced by all living things.
Few things annoy me more than to hear people talking about carbon dioxide as being a pollutant. You're made of carbon dioxide. I'm made of carbon dioxide. Carbon dioxide is how living things grow.
What's more, humans are not the main source of carbon dioxide.
Humans produce a small fraction in the single digits percentage-wise of the CO2 that is produced in the atmosphere.
Volcanoes produce more CO2 each year than all the factories and cars and planes and other sources of man-made carbon dioxide put together. More still comes from animals and bacteria, which produce about 150 gigatons of CO2 each year, compared to a mere 6.5 gigatons from humans. An even larger source of CO2 is dying vegetation, from falling leaves, for example, in the autumn. But the biggest source of CO2 by far is the oceans. Carl Wunsch is Professor of Oceanography at MIT. He was also visiting Professor in Oceanography at Harvard University and University College London, and a Senior Visiting Fellow in Mathematics and Physics at the University of Cambridge. He is the author of 4 major textbooks on oceanography.
The ocean is the major reservoir into which carbon dioxide goes when it comes out of the atmosphere, or from which it is re-emitted to the atmosphere. If you heat the surface of the ocean, it tends to emit carbon dioxide. So similarly, if you cool the ocean surface, the ocean can dissolve more carbon dioxide.
So the warmer the oceans, the more carbon dioxide they produce, and the cooler they are, the more they suck in. But why is there a time lag of hundreds of years between a change in temperature and a change in the amount of carbon dioxide going into or out of the sea? The reason is that oceans are so big and so deep, they take literally hundreds of years to warm up and cool down. This time lag means the oceans have what scientists call a memory of temperature changes.
The ocean has a memory of past events running out as far as 10,000 years. So, for example, if somebody says, "Oh, I'm seeing changes in the North Atlantic," this must mean that the climate system is changing. It may only mean that something happened in a remote part of the ocean decades or hundreds of years ago, whose effects are now beginning to show up in the North Atlantic.
The current warming began long before people had cars or electric lights. In the past 150 years, the temperature has risen just over half a degree Celsius. But most of that rise occurred before 1940. Since that time, the temperature has fallen for 4 decades and risen for 3. There is no evidence at all from Earth's long climate history that carbon dioxide has ever determined global temperatures. In a way, it's not surprising. The sun affects us directly, of course, when it sends down its heat. But we now know the sun also affects us indirectly through clouds. Clouds have a powerful cooling effect, but how are they formed? In the early 20th century, scientists discovered that the Earth was constantly being bombarded by subatomic particles. These particles, which they called cosmic rays, originated, it was believed, from exploding supernovae far beyond our solar system. When the particles coming down meet water vapor rising up from the sea, they form water droplets and make clouds. But when the sun is more active and the solar wind is strong, fewer particles get through and fewer clouds are formed. Just how powerful this effect was became clear only recently, when an astrophysicist, Professor Nir Shaviv, decided to compare his own record of cloud-forming cosmic rays with the temperature record created by a geologist, Professor Jan Weitzer, going back 600 million years. What they found was that when cosmic rays went up, the temperature went down. When cosmic rays went down, the temperature went up. Clouds and the Earth's climate were very closely linked. To see how close, you just flip the lines.
We just compared the graphs, just put them one upon the other, and it was just amazing. Jan Weiser looked at me and says, you know, we have very explosive data here.
I've never seen such vastly different records coming together so beautifully to show really what was happening over that long period of time.
The climate was controlled by the clouds. The clouds were controlled by cosmic rays. And the cosmic rays were controlled by the sun. It all came down to the sun.
If you had X-ray eyes, what appears as a nice, friendly yellow ball would appear like a raging tiger. The sun is an incredibly violent beast, and it's throwing out great explosions and puffs of gas, and endless solar wind that's forever rushing past the Earth. We're, in a certain sense, inside the atmosphere of the sun. The intensity of its magnetic field more than doubled during the 20th century.
In 2005, astrophysicists from Harvard University published the following graph in the official journal of the American Geophysical Union. The blue line represents temperature change in the Arctic over the past 100 years. And here is the rise in carbon dioxide over the same period. The two are not obviously connected. But now look again at the temperature record, and at this red line, which depicts variations in solar activity over the past century as recorded independently by scientists from NASA and America's National Oceanic and Atmospheric Administration.
Solar activity over the last 100 years, over the last several hundred years, correlates very nicely on a decadal basis with sea ice and Arctic temperatures.
To the Harvard astrophysicists and many other scientists, the conclusion is inescapable.
The sun is driving climate change. CO2 is irrelevant.